Welcome back to today's session. As I told yesterday, we will be solving one quite a complex problem or quite a lengthy problem on optimization and degeneracy case. See, I'm considering this problem because in this problem, we do not have degeneracy in the beginning, but degeneracy appears in between, it goes off, once again it comes. So, uh, various scenarios of degeneracy case are involved in this problem. That's why I've taken this problem. Uh, as I told, this is a lengthy problem. Therefore, I'll be a bit fast with all the general or the initial stages of computing IBFS, calculating UIVJ values, calculating EIJ values. I'll be a bit fast. And wherever there is a need for me to explain in detail, I'll go slow there. Hope it is fine with you people. So the problem given is we are supposed to solve the transportation problem IBFS using NWCR and optimize it with Modi method. So we have 4 origins and 4 destinations. So first thing that we are supposed to do is check whether the problem is balanced or not. So when we add up the supplies and the demands, we find that the total is 80 on both sides, so it is a balanced problem. So I am solving IBFS using NWCR. So the first allocation will be the top left corner with 21 units. So 1, 1, 21 units. Just a minute, let me pick a highlighter. Okay, the first column is gone now. Next, the top left corner is 1, 2. So I'll make an allocation of 13 units. So 1, 2, 13 units. So first column and the first row is gone now. Top left corner is 2, 2. So I'll make an allocation of 12 units. So first column, second column, and the first row are gone now. Now the top left corner is 2, 3. So I'll make an allocation of 3 units here. So at 2, 3, 3 units. So the first row is gone, second row is gone, first column is gone, and the second column is gone. Fine. Now in the remaining matrix, the top left corner is 3, 3. So I make an allocation of 12 units here. So 3, 3, 12 units. So the first column is gone, second column is gone, then the first row is gone, second row is also gone, third row is also gone. Now the top left corner is 4, 3. So I make an allocation of 2 units here. So 4, 3, 2 units. So the first column, second column, third column, the first row, second row, and the third row are gone. Right? I am left out with a single cell. Whenever there is a single cell left out, I have already told you the supply and demand would match. So 17, 17. So the satisfy 17 units. So the last column and the last row both will go. So the IBFS that I've got is 1, 1, 21 units, 1, 2, 13 units, 2, 2, 12 units, 2, 3, 3 units, 3, 3, 12 units, 4, 3, 2 units, 4, 4, 17 units. So when I compute the TTC for this, it will be 21 into 1 plus 13 into 5 plus 12 into 3 plus 3 into 1 plus 12 into 2 plus 2 into 2 plus 17 into 4. So which will be 21 plus 65 plus 36 plus 3 plus 24 plus 4 plus 68. So overall the total TTC will be 221 rupees. Now we are supposed to optimize this. So for optimization, first I'll have to check for degeneracy. So how many allocations I have? 1, 2, 3, 4, 5, 6 and 7. So totally 7 allocations I have. For it to be a non-degeneracy case, I require m plus n minus 1 allocations. M is the number of rows 4, Yeah, n is the number of columns 4. So 4 plus 4, 8. 8 minus 1 is 7. I am supposed to have 7 allocations. I have 7 allocations. Therefore, the problem is non-degeneracy case at this particular level. So I try to solve it or optimize it using Modi method. So apply the method. See here only this column has the highest number of allocations, that is 3 allocations. So I put a 0 here. So based on that, these 3 elements will become the key elements. So I get the UI values, corresponding UI values as 1, 2 and 2. So now I'll take this 1 as reference. Oh, sorry, I've taken 2 as reference. So 4 minus 2 becomes a 2. Next, I take this 1 as reference. 3 minus 1 will be 2. Now I'll take this 2 as reference. 5 minus 2 is 3. Now I'll take this 3 as reference. 1 minus 3 is minus 2. So I've got all UI and VJ values. Now compute the EIJ values. 3 minus 3 minus 0 will be a 0 here. 3 minus 3 minus 2 will be a minus 2 here. Then 3 minus 1 minus of minus 2. 3 minus 1 is 2, 2 plus 2 is 4. So I get a 4 here. At this place, 2 minus 1 is 1, 1 minus 2 is minus 1. So I get a minus 1 here. 0 minus 2 is minus 2, minus 2 or minus of minus 2 will be a 0. So I get a 0 here. So 2 minus 2 is 0, 0 minus 2 is minus 2. So I get a minus 2 here. 3 minus 2 is 1. 3 minus 2 is 1 and 1 minus 2 is minus 1. I get a minus 1 here. 2 minus 2 will be 0. 0 plus 2 will be a 2. Then 7 minus 2 is 5. 5 minus 2 is 3. So I get minus 2, minus 1, minus 1, minus 2. So I get minus 2, highest negative value in 2 places. Fine. So just have a look. I've got minus 2 in 2 places. So I'll pick this minus 2 as the most negative EIJ and I'll take this as reference. So this will be the first point. So from here I get a continuation to this point, from here to here and here to here and back to the original position. So in the alternating way, starting from the first position, plus theta here, minus theta here, plus theta here and a minus theta here. So theta value will be minimum of minus theta positions. At minus theta positions, you have allocations 12 and 12. So theta will be minimum of 12 comma 12. So therefore, so theta value will be 12 itself. So substitute that theta value as 12. So what happens? This 12 will appear here. So I get a 12 here allocation. This allocation will become a 0. This allocation will become 15. This allocation will once again become a 0. Right? So just have a look. 21, 13. This became a 0. This became a 12, 15, 0. This 2 and 17 which are untouched. So now how many allocations we have? 1, 2, 3, 4, 5, 6. So we observe that we have only 6 allocations. But actually you were supposed to have 7 allocations. Therefore, this is a degeneracy case. I am supposed to apply an epsilon value. So for applying epsilon value, For applying epsilon value, I am supposed to pick the least cost. If at all I consider least cost 0 and I put epsilon here, so what happens is automatically it forms a loop. So this is not an independent position. So they have very clearly specified put an epsilon at least cost, which is an independent position. It should not by default form a loop. So therefore, I will not pick this. I will look for the next least cost. Next least cost is 3, 3, 3, 3, 2, 2, 2, 7, right? So next least cost is 2. So I'll have to pick a position with least cost 2 to make an epsilon allocation. So make an allocation epsilon at position 2. Now the number of allocations became 7. So it is non-degeneracy case as of now. So apply Mori method to continue. So I'll have to take 0 here because I have 3 allocations. So using this as reference, I get the UI values as 1, 2 and 2. So I'll take this 2 as reference. So 4 minus 2, I get a 2. Next I'll take this 2 as reference. 2 minus 2 will be a 0. Now I'll take this 0 as reference. 5 minus 0 will give me a 5. So I'll take this 5 as reference. 1 minus 5 is minus 4. Okay, all the UI and VJ values are calculated. Now compute the EIJ values. 3 minus 5 is minus 2. Minus 2 minus 0 is minus 2 only. So I get a minus 2 here. So 3 minus 5 is minus 2. Minus 2 minus 2 is minus 4. So I get a minus 4 here. Then 3 minus 1 plus 4. So it is 6. 3 minus 1 minus 0 is 2. Then 2 minus 1 minus 2 is minus 1. 0 minus 2 plus 4 is 2. 3 minus 2 minus 2 is a minus 1. 2 minus 2 plus 4 is 4. 7 minus 2 minus 0 is a 5. So I get negative in 4 places. Minus 2, minus 4, minus 1, minus 1. So the most negative is minus 4. The most negative is minus 4. I'll take this as point of reference. So from here I move down. I get a continuity here. From here I move to this position. From here I move to this position. From here I move up and back to the original position. So the closed figure that I get is not a quadrilateral in this case, but a hexagon, right? So starting with the starting point, put alternating signs. So I get a plus theta here, minus theta here, plus theta, minus theta, plus theta, and a minus theta, right? Theta will be minimum of minus theta allocations. So wherever you have minus theta, 13, then I have an epsilon, and then I have a 17. So out of 13 and 17 and epsilon, whichever is minimum has to be considered. So we know that epsilon is a very small value. So therefore epsilon is minimum. So theta value will be epsilon. So here when I add epsilon, it will become 12 plus epsilon. Here it will be 13 minus epsilon. This 15 will be unchanged. Epsilon minus epsilon will become a 0 allocation. Here it will be 2 plus epsilon. Here I will get an epsilon allocation. And in this particular location, I will get 17 minus epsilon. So have a look. It becomes 21, 13 minus epsilon, 12 plus epsilon, 15, 2 plus epsilon, epsilon, and 17 minus epsilon. Right? So how many allocations we have? 1, 2, 3, 4, 5, 6, and 7. So totally we have 7 allocations. Therefore, it is a non-degeneracy case. So here in this row, I have 3 allocations. Therefore, that will get a UI value as 0. So using that as reference, I get Vj values as 1, 5 and 3. So using this 5 as reference, 2 minus 5 will be a minus 3. Now I can use this 3 as reference. So I get 4 minus 3 as 1. So now I'll use this 1 as reference. 2 minus 1 is 1. Now I'll use this 1 as reference. 1 minus 1, 0. So all ui and vj values are obtained. Now compute the eaj values. So 3 minus 0 is 3. 3 minus 1 is 2. Here 3 minus 0 minus 1 is a 2. Here I get 3 minus 0 minus 5 is a minus 2. 2 minus 0 minus 3 is a minus 1. 0 plus 3 minus 1 is a 2. 2 plus 3, 5. 5 minus 1 is 4. So at this location, 3 plus 3 is 6. 6 minus 3 is 3. 2 minus 1 minus 1 will be a 0. Here I get 7 minus 1 minus 5 is a 1. So all the EAJ values are computed. Only in two locations I get negative value. Net evaluations is negative in two places. In one place it is minus 2, in the other place it is minus 1. So the most negative is minus 2. So I'll take this as point of reference. So I'm supposed to form a loop. So from here I'll move up by one location. From here I'll move to the end, downwards, then one position to the left and again to the top and back to the original position. So this forms a closed loop as a hexagon. So put a alternating signs for theta. So you get plus theta. Here you get a minus theta, a plus theta, a minus theta, a plus theta and a minus theta here. So theta value will be minimum of all the minus theta allocations. So where all you have minus theta? 13 minus epsilon. Then one more minus you have at 15. And one more minus you have at 17 minus epsilon. So theta will be minimum of 13 minus epsilon, 17 minus epsilon and 15. So epsilon is a very negligible value. So only the numerical values you can just compare. So minimum is 13. So 13 minus epsilon is the minimum value for theta. So I get this theta minus epsilon will become a 0. So this will become a 0. Here I will get 13 minus epsilon. Then here I will get 2 minus epsilon. Here I will get 15 plus epsilon. Here I will get 4 minus epsilon. 4, that's all. And this epsilon will get cancelled. Right? So the new allocations that I get will be 21, 13 minus epsilon, 12 plus epsilon, 2 plus epsilon, 15, 13 and 4. So how many allocations we have now as of now? 1, 2, 3, 4, 5, 6 and 7. Totally 7 allocations are there. So how many we were supposed to get? It is 7. So it satisfies the non-degeneracy case. So because it is non-degeneracy case, so we can straight away go apply Modi method for this. So when you apply Modi method, what happens? You can arbitrarily pick any one of them for a 0 assignment because most of them have 2 allocations. So I'll pick D2. So I'll make a 0 allocation here. So these two will become key values. 3 minus 0 will be a 3. 2 minus 0 will be a 2. Okay. Now I'll consider this 3 as reference. 1 minus 3 is minus 2. Okay. Now I'll consider this minus 2 as reference. 2 minus of minus 2 is a 4. So I'll consider this 4 as reference. 4 minus 4 is a 0. I'll consider this 0 as reference. 3 minus 0 is a 3. I'll consider this 3 as reference. 1 minus 3 is a minus 2. So all ui and vj values are obtained. Now apply or compute the net evaluations eij values. 5 minus 3 is a 2. 3 minus 3, 0. 0 plus 2 is a 2. 3 minus 3 is a 0. 0 plus 2, you get a 2 again. Then 2 minus 3 is minus 1. So I get a negative value here, minus 1. 0 minus 2 is minus 2. Minus 2 plus 2 is a 0. So I get a 0 here. 2 minus 2, 0. 0 plus 2 is a 2. Then here I get 3 minus 2 is 1. 1 minus 0 is 1. 2 minus 4 is minus 2. Minus 2 minus of minus 2. You get a 0 again. 7 minus 4 is a 3. 3 minus 0 is a 3. So you get only one place which has a negative net evaluation values minus 1. So that will be considered as a point of reference. So I'll consider this as a point of reference. From here I'll move down, then left, then top. So the closed figure that I get is a quadrilateral. So now evaluate the theta value. Theta is minimum of minus theta allocations. Minus theta allocations is 2 plus epsilon and a 4. So out of these two, which is minimum? So 2 plus epsilon is minimum. Therefore, theta value is considered as 2 plus epsilon. So this 2 plus epsilon will become a 0. Here I will get a 2 plus epsilon. Here I will get minus 2 will become 2 plus epsilon. Oh, sorry, 2 minus epsilon. Here I will get a 2 minus epsilon. Here 15 plus epsilon, 15 plus 2 is 17. 17 plus epsilon. I will get 17 plus epsilon. Right? So the new allocations that I've got are 21, 13 minus epsilon, 12 plus epsilon, 17 plus epsilon, 13, 2 plus epsilon and 2 minus epsilon. When you add up and check, still the conditions are satisfied. 13 plus 2 is 15, 15 plus 2, 17. Here also it is 17. 13 plus 12, 25, 21. So 21 plus 13, 34. 13 plus 2, 15, 12. Then 17 plus 2, 19. All this are matching. Find out the total number of allocations that you have. 1, 2, 3, 4, 5, 6 and 7. Right? I have 7 allocations. Therefore, it is a non-degeneracy case. So I have taken 0 here. So this becomes the key values. 2 minus 0 is 2. 4 minus 0 is a 4. So I'll take this 4 as reference. So 3 minus 4 is a minus 1. 2 minus 4 is a minus 2. Then I'll take this minus 1 as reference. 1 minus of minus 1 will be a 2. Then I'll take this minus 2 as reference. 3 minus of minus 2 is a 5. So I'll take this 5 as reference. 2 minus 5 is a minus 3. Okay. So all ui and vj values are obtained. Now compute the eij values, net evaluations. 5 minus of minus 1 is 6. 6 minus 5 is 1. 3 minus of minus 1 is 4. 4 minus 2 is a 2. Here 3 minus of minus 2 is 5. 5 minus 2 is 3. 1 minus of minus 2 is 3. 3 minus 2 is 1. Then here 0 plus 3 minus 2 is a 1. 2 plus 3 is a 5. 5 minus 2 is a 3 again. 3 plus 3, 6. 6 minus 4, you get a 2. So 2 minus 0 is a 2. 2 is a 0. I get a 0 here. So 7 minus 0 minus 5 is a 2. So I get all the net evaluations, all EIJ values as positive, right? 1, 2, 3, 1, 1, 3, 2, 0 and 2. In this problem, we observe that we have a 0 net evaluation, a 0 in this particular case. So what does it mean? As all EIJ values are positive, the optimal solution is obtained. But it has an alternate solution because I have one of the EIJ values as 0. So whatever solution I have obtained, this is one possible solution. You can have another solution for the same problem with same TTC value. Okay, that is what it means. So now we are supposed to compute the TTC. The TTC will be 21 into 1 plus 13 into 3 plus 13 minus epsilon into 3 plus 2 plus epsilon into 2 plus 12 plus epsilon into 2 plus 17 plus epsilon into 2 plus 2 minus epsilon into 4. So when you multiply it, 2 into 1 is, 21 into 1 is 21, 13 into 3 is 39, 13 minus epsilon into 3 is 39 minus 3 epsilon, 2 plus epsilon into 2 is 4 plus 2 epsilon, 12 plus epsilon into 2 is 24 plus 2 epsilon, 17 plus epsilon into 2 is 34 plus 2 epsilon, 2 minus epsilon into 4 is 8 minus 4 epsilon. So all the individual numerical values I'll add up. 21 plus 39 plus 39 plus 4 plus 24 plus 34 plus 8. I get 169. Now all the epsilon values. Minus 3 epsilon plus 2 epsilon is a minus epsilon. Minus epsilon plus 2 epsilon is an epsilon. Epsilon plus 2 epsilon, 3 epsilon. 3 epsilon minus 4 epsilon is minus epsilon, right? So I get minus epsilon here. 169 minus epsilon. Epsilon is a very negligible value. You can just ignore it. So I get the final TTC as 169 rupees. So hope you have understood handling degeneracy case in transportation problem. Whatever complex problem I have solved now, such complex problems will not be given in the exam, but still for you to know the procedure perfectly, I've taken this complex problem. Hope you people have understood. Thank you. Thank you for your patient listening. Have a nice time. Enjoy. Kindly stay at home and stay safe.